Good morning, guys.
Monica.
All are here. Guys, shall we start the present? Albert Stone Matthew,
I'm here.
but the area,
Here, sir.
then Carpenter Caleb. Carpenter Caleb. Okay. Davis Alexis. Davis Alexis. Glasgow Robert.
Here.
Okay. Gonzalez Judith.
Here.
Heavener Cameron.
Yes, sir.
General Christopher.
Yes, sir.
Jarka Andrew.
Here, sir.
Liney Cooper. Liney Cooper. Maza Hilwe Lazara.
Here, sir.
Then Pardue, Virginia.
Here, sir.
Powell Walker.
Yes, sir.
Peyton.
Yes, sir.
Sheriff Charles.
Yes, sir.
Simon Rice. Simon Rice. Soto Jonathan.
Here, sir.
Taylor Ismail. Taylor Ismail. Tun Nicholas. Tuna Nicholas. And West John Marshall.
Here, sir.
Again, guys, Carpenter Caleb. Davis Alexis.
Yes, sir.
Where is he? Please don't waste time, please.
I'm sorry.
Davis
I didn't
Car.
look at you.
Davis Car. Okay. Alexis Davis. Okay. Then Liney Cooper. Liney Cooper. Okay. Then Simon Rice. Simon Rice. Then Taylor Ismail. And then Tony Nicholas. Okay. 1, 2, 3, 4, 5. Okay. Okay, guys. So let's start. Let me just share my screen. So yesterday we started the area enclosed by the curve, and I took this first example. I explained to you, look at over here, two functions were provided to you. Quadratic functions are there, parabolas are there. I told you how to draw the graph of the function. If you equate these two functions, that means you're going to get the point of intersections. And once you have the point of intersection, then after I told you that we are just moving from your right to left and then top to bottom, right? So this way you need to do this thing. So look at over here, top to bottom, that means once you have your strip over here, and if you are taking vertical strip, means you are integrating with respect to x. Please keep in mind this thing. I have chosen over here vertical strip. Another thing is, yeah, please be careful, guys. Another thing is, once you decide your strip, that means there should not be any change in the top of the strip, at the top of the strip as well as the bottom of the strip. That means strip should not change the behavior. Same function should be there throughout the region. If I take this strip over here at the initial point, and then after I took the partition 1, 2, 3, and you can see for each of the partitions 1, 2, 3, my top nature of the strip and the bottom nature of the strip remains the same. Bottom nature, look at over here, throughout the region, the bottom part, that is this function, 2x squared plus 5x minus, or it may be. And top part throughout the region, it is this one. Suppose your strip, suppose after some times your function changes the behaviors, another function interrupts. In that case, you have to divide your region into two parts. So please make sure that your strip should not change the behavior in terms of the nature of the functions, top and bottom, throughout the region. If your region, if your strip, either top part or bottom part, changes the function, that means you have to divide the region 2 times, 3 times, depends how which type of figures you are working with or how many functions you are working with. Area is given by top part fx minus gx. I told you that suppose you are given fx, this one, and gx, just interchange this one. Interchange means don't interchange the function. You are not allowed to make any kind of changes in the function. Just take this function as it is, this as it is, but the top function you can say your fx and bottom function you can say gx. So area is integration a to b fx minus gx dx. Fx is top function minus gx, so that you are going to get your area positive. Otherwise, you know what will happen? You will be getting some negative number, and you know that area cannot be negative. You know this thing that area cannot be negative. So please keep in mind this thing, because if you are taking the reverse way, means you are losing your points like this. Okay, so we did this example. Let me go through one more example. Fx equal to sin x. Sin x, you know, that is between the range of 0 to 2 pi, you can say. I just forgot to mention this thing, but your x belongs to 0 to 2 pi. So x runs from 0 to 2 pi. You can see over here, my sine function moves like this. Sine 0 is 0, sine pi by 2 is 1, this is 1. And sine pi equal to 0, sine 3 pi by 2 is negative 1, sine 2 pi is again 0. You know this thing. This is the graph of the sine function. And another function is gx equal to 2x, means y. I don't say this fx and gx, I give it to you, but I would say just this is my y and this is my y. Just y and y. And then after drawing the picture, I will decide that which is the upper part of my strip and which is the lower part of the strip. Upper part of the strip corresponding function I would like to say as my fx, and the lower part of the strip touches the function, that corresponding function I would like to say as my g. So whatever is given to you, just don't worry about it. Just say this one as y, this one as y. Okay. So my gx is 2x, a linear function, pi is constant, so y equal to 2x over pi. Pi is just constant, so y equal to 2x, a linear function, passes like this. If you want to find the point of intersection, in that case, you can equate these two functions, sin x equal to 2x over pi. Sin x equal to 2x over pi. You can do like this. Okay, now, but how will you equate these two functions? One side you have polynomial or linear function, other side you have trig function, right? So what I'm going to do, if I draw the picture, if you look at the picture, you can see over here that my graph intersects. So both graphs, they intersect over here at 0, 0, and some point over here. It looks like this at pi by 2. Look at over here. Let me start with 0, 0. So if I take x is equal to 0, so sine 0 is 0, x equal to 0, 0 times 2 times 0 equal to 0. So I would say that my 0 equal to 0 means x equal to 0 is the first point of intersection. First point of intersection. Second point you can see over here, sine pi by 2 is very natural that sine pi by 2 is 1, right? Sine pi by 2 is 1, and you can see here this point is also 1. So see sine pi by 2 is 1, right? And 2 and x equal to pi by 2, because x equal to pi by 2, x equal to pi by 2. If you take pi over here, pi and pi will get cancelled out, pi by 2, 2 and 2 will get cancelled out, right hand side is also 1. So x equal to pi by 2 also satisfies this equation. And that's why I would say that this pi by 2 is the another point of intersection. X equal to pi by 2 is the another point of intersection. Once I have x equal to 0, so naturally if you plug this x equal to 0 in any one of these two equations, y equal to sine x and y equal to 2x over pi, x equal to 0 means y equal to 0, and x equal to pi by 2 means y is equal to 1. So 0, 0 and pi by 2, 1, that is the point of intersection. 0, 0 and pi by 2, 1. This is my pi by 2 and 1. Now, I am taking my vertical strip over here. You can work with horizontal strip too. Again, let me remind you, just now I told you that whenever you are working with the vertical strip, that means you are integrating your function with respect to x. If you are taking horizontal strip, means you are integrating your function with respect to y. Reverse case, you will be studying the same, the reverse case in your Calc 3, right? I don't want to disclose that thing right now, because I don't want to confuse you. So please keep in mind this thing, that vertical strip means integrating with respect to x, because you are taking the strip at the initial point and then after you're moving along x-axis to cover the whole region, right? And if you have the horizontal strip, that means you are taking the strip over here and then after you are moving in upper direction along y, horizontal this to cover the whole region. So that's why you are integrating with respect to y. Okay, good. So vertical means integrating with respect to x. So x range is 0, 0 to pi by 2 and 1. So 0 to pi by 2 is my range of x. So x runs from, let me write more precisely here, it should be x equal to 0 to pi by 2. Fx is my top function. Fx is my top function, and this top function corresponds to the sine. That means it is sine function, and bottom function is my 2x over pi. That is my g function. So fx and gx, whatever is provided to you, that is in the right order. So I would say that fx minus gx, sine x minus 2x over pi, integration, term by term integration, sine is negative cosine, negative 2 over pi is common, and x integration is x squared by 2. And then after, use the second fundamental theorem of calculus, replacing x by the upper limit and then the x by the lower limit and in between negative sign. So x by upper limit, so cosine of pi by 2 is 0. Here you are going to get pi and pi will get cancelled, so simply pi by 4. This is negative. Cosine 0 is 1, right? So negative 1, negative will be positive 1. So you are getting 1 minus pi by 4. So this 1 minus pi by 4, that is your region, that is your area. Somebody says that I want some fixed number, that's fine. Just replace your pi by 3.14 or 22 by 7 like this, 3.14, and you will be getting some number, maybe real number. I would say maybe rational or irrational number, but ultimately real number. So that will be the area enclosed by these two curves. Any doubt in this example, guys? Any doubt in this example?
No, sir.
Okay. Good. Again, let me just go through this one, guys. Carpenter, Ismail. These guys are not here today. Okay. Today is June 3rd, right?
It's June 4th, sir.
June 4th.
Okay.
Or did you get Cooper Lane?
Who is that?
Cooper Lane.
Cooperland. So please try to come in time. I spoke your name twice.
Yes, sir.
Huh. Okay, stop sharing and let me go through again. Oh, I'm sorry. Okay, let me just go through. What is the name? Cooperland?
Yes,
Cooper,
sir.
right? Cooper
Yes, sir.
Lane. Okay. Cooper. Okay. Cooper is present. If somebody else is also there, please let me know. Okay. Good. Let's go for the next example, guys. Next example. Y equal to x and y equal to root x. Now y equal to root x means if you take the square both the sides means you're going to get y square equal to x. And y square equal to x is a parabola. It's a parabola like this. in first and fourth quadrant, y square equal to x. That means y equal to root x is the parabola in the first quadrant and y equal to negative root x is the parabola in the second quadrant. But we are given just y equal to root x, means just parabola in the first quadrant. So we don't draw the picture over here. If you want to draw the picture, that's fine. But actually you are given just the upper part of the parabola, means first quadrant. Y equal to x straight line. Point of intersections, just equate these two equations. So x equal to root x, squaring both the sides, x square equal to x square minus x equal to 0, x common, x minus 1 equal to 0. 0 product rule, x equal to 0 and x equal to 1. So x equal to 0 and x equal to 1, just plug these values in either of these equations, you're going to get y equal to 0 and y equal to 1. So 0, 0 and 1, 1, these are the points of intersections. Again, let me take this vertical strip over here, means we are moving along the x-axis. So x equal to x runs from 0 to 1, x runs from 0 to 1, and top function is root x, bottom function is x, so root x minus x. Term by term integration, 1/6 means point what? 1/6, that is the answer, right? 0.3, something like that, what it may be. So that is the answer, 1/6, that is the answer, that is the area between these two curves. Good. Area between these two curves. Yeah, I drew the wrong picture over here. Just cancel it and just pay attention here. Okay. So next example, fx equal to x square minus 3x plus 2, gx equal to negative 3x plus 3, right? So this is a parabola. This is a straight line. Parabola runs like this. You know how to draw the picture of a parabola, x square minus 3x plus 2. If somebody says that I don't know how to draw the picture, I would say like this, that x square minus 3x plus 2 equal to 0. Suppose take like this and then make a perfect square on your left side. So x square minus 3x plus 2, right guys? So you can make a perfect square and then you can draw the picture like this. So this is the parabola. Okay, and straight line is like this. Top function is a straight line. So this is my fx and this is my gx, right guys? And if you solve these two, you're going to get x equal to negative 1, x equal to negative 1 and 6. That is the first point of intersection by solving these two equations, and y x equal to 1 and y equal to 0 is the another point of intersection. Another point of intersection. Good. And then after, I would like to take my limit, because we are taking the vertical strip, means integration with respect to x. So we are running from x equal to negative 1 to positive 1. So negative 1 to positive 1. Top function is the straight line, negative 3x plus 3, minus bottom function is the parabola, x square minus 3x plus 2. And just open the bracket, cancel the common things. And then after, take the term by term integration. Negative x squared plus 1 integration is negative x cubed by 3. 1 integration is x. Second fundamental theorem of calculus. Solve this one and you are getting 4 by 3 as the answer. Does it make sense? Does it make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Good. Okay, guys. Now I want to take the another example. These all are the examples from your practice test. Whatever I taught you so far, these are the examples from your practice test. Question number 1, where we just found the simple area, simply area. Now I would like to go for the second problem. Look at over here. In the second problem, it says to find the area, first of all, with respect to x, and then with respect to y. That means you are asked, now you are asked to integrate your function first with respect to x, and then you are asked to integrate your function first with respect to y, right? With respect to x, that means other way around, you are asked to take the vertical strip first, and then after the second problem, you are asked to take the horizontal strip, because just now I told you twice that vertical strip means integration with respect to x, horizontal means integration with respect to y. Good. Figure is given to you. Now, here I gave you the equation of the line, but that will not be provided to you every time. But instead of that, I have given you these points. So look at over here. This is 1 and this one is 1. So this point, look at my cursor, that is 1, 1. I have 2 over here. I have -1 over here. So this point is 2 and -1. And naturally, this one is 0, 0. Once you have these 3 points, that means you can write the equation of a line. You can consider any one of these 2 points as y1 minus x1 y1 and x2 y2, or x0 y0 and x1 y1, like this. And then after, you can find the slope. You know that thing, right? Y minus y1 equal to m times x minus x1, right? Y minus y1 equal to m times, m is a slope, and slope is nothing but y2 minus y1 over x2 minus x1. So find that slope. Once you find the slope, then after plug that slope, that value y minus y1. Are you getting me, guys, or you want me to draw this picture and explain to you?
Can you draw the picture?
So here it is. Let me stop sharing. Oops. I want to close my file. Where is it? Stop sharing, right? So stop sharing, and let me now share my whiteboard. Okay, guys. So it will be something like this. Suppose you have like this, and here it was something like this, right? And then after something like this and something like this was there. So this point was 2 and -1, and this point here it is 1. So this point was 1 and 1, if I'm not wrong. And this point was 0 and 0. Suppose you are given these points, right? Suppose you are given these points. In that case, how can you find the equation of a line? Right? Suppose this is actually a parabola, so you can't do anything over here, but let me take this one. This is a straight line. This is a straight line. Okay, so I would like to consider, first of all, my m is a slope that is equal to y2 minus y1 divided by x2 minus x1. That is my slope. So I would like to consider this one as x1, y1, and this one as x2 and my y2 point. Okay, so if you plug the values over here, so y2 is equal to -1, y1 equal to 0. So -1, oops, what is this? Okay, so that is equal to y2 equal to -1, y1 equal to 0 divided by x2 equal to 2 and x1 equal to 0. That means it is -1/2 is the slope, right? Then after, I can plug the value in the equation of the line, that y minus y1 equal to m times x minus x1. So y minus y1 equal to 0, m equal to -1/2, and x minus 0. That means y equal to negative of x/2, right? Y equal to negative of x/2. So that's how you can find the equation of the line, y equal to negative of x/2, or you can say x equal to negative of 2y, like this. Same way you can find the equation for this one, right, guys? So that's what I mean by the equation of lines. May I erase this part?
Yes, sir. Thank you.
Okay, so clear this one. Let me close this one. Oops, right. Okay, and then again, let me go for the screen sharing. Before I go for the screen sharing, I just would like to go for the presence again, because I don't want anybody to miss this part. Number 5, Carpenter Caleb.
Yes, sir.
Carpenter Caleb, are you there?
Sorry, I had connection issues earlier and my internet wouldn't work at all, but I finally
I
got it
spoke
working.
your name more than 5-6 times. Please fix it.
Right, but
Okay.
I had internet issues, so I couldn't
That's
connect.
fine. Yeah, I can understand.
I connected around 7:55 though, so I haven't been absent for that long.
Okay. Yeah, we started at 7:45. That's fine.
Right.
Number 12 is Liney Cooper. He is here. Yes, he already told me. So Cooper is here now. Carpenter is here. Number 18 is Simon Rice. Simon Rice.
I think he just got on, sir. I think he's on his iPhone. He's probably having connection issues as well.
Oh, Simon too. Oh my gosh. Okay. And then after Simon Rice, number 20. Taylor Ismail. Okay. And Tony Nicholas.
Did Toon say that he was going to be on a flight this morning? Yesterday?
Oh, yes. Yeah, he already told me this thing. Okay, Nicholas. So only two guys are absent, right? Simon and Ismail. Okay. I need to send the email to them. Okay, guys, let's continue. So now let me close this one and let me again share my screen with you guys. Okay, so that's how it works. Look at over here, y equal to negative of x by 2. That's what the equation of line I got. Same way you can find this equation of line like this is the parabola. Okay, now guys, look at over here. Suppose I want to take the vertical strip. All you guys please pay attention over here and try to look at my cursor thoroughly, please. This is my vertical strip. My vertical strip, the top part is my function y equal to root x parabola. Bottom part is the function y equal to negative x by 2 linear function line. Right? Now, what is the process? Process is we take this strip at the point over here and try to strip this strip from this initial point to final point. This strip the initial point to final point, right? To cover the whole region. Okay, but what will happen if I have a strip over here? If I move this strip like this in the right direction, after the point after this point, my bottom part of the strip remains same, but the top part of the strip changes the function. Can you see over here? My top part changes the function. That's why I have to put one dotted line over here like this, dotted line here. You have to put a dotted line over here. All of you are able to see the screen?
Yes, sir.
Okay, so I have to put one dotted line over here, and your dotted line indicates that you are dividing your region into two parts. So part 1 and part 2. That means you have to have two separate integrals like this. Please try to follow my cursor. So two different integrals like this. My x runs from 0 to 1 over here. So my x runs from 0 to 1 here. And then after my x runs from 1 to 2 to cover the rest of the part, 1 to 2. Top part is root x. So my formula, my area will be top minus bottom. So root x minus x by 2. So root x plus x by 2 and dx. Second part, my function y equal negative 2x plus 3 minus plus x by 2. Negative 2x plus 3 plus x by 2. Once you set up your integral, you're almost done. Only the matter of simple integrals. So if you take x to the power half, power rule, integration is this one. Again, power rule, x squared by 2, constant, you can pull it out. Negative of 2x squared by 2, and x is, okay. You can see over here, that is negative 2. You can merge these two, or you can take the separate integrals, that's fine. Here it is 1 by 2 is x squared by 2, and here is 3x, right? You can merge these two because x and x are same. So you can write 1 by 2 minus 2. Right? So that is equal to negative 3 by 2. So negative 3 by 2 and x is x squared by 2. Integration of 3 is 3x. Okay, and then limit 0 to 1 and 1 to 2. Second fundamental theorem of calculus. Here and here, finally 5 by 3 is the answer. 5 by 3 is the answer. Okay, now second part says that take the integration with respect to y. Same region, take the integration with respect to y. That means now I have to consider the horizontal strip. But again, the same scenario will be there. If I take, look at over here, my strips will be like this now. Look at my cursor. My strip will be like this. If I take the strip like this, my left behavior of the function, left side function is linear function y equal to negative x by 2. Actually, you have to now Here is a function of x and x because we integrated with respect to x. But now we are asked to integrate the function with respect to y. That means you have to have a function of y here, here, and here. So y equal to root x. Y equal to root x. So what is the value of x? X equal to y square. Agree?
Yes, sir.
Yes,
X
sir.
equal to y square.
Yes, sir.
What is the value of x here? X here? What is the value of x here? 3 minus y divided by 2. Agree?
Yes, sir.
X equal to, take this 2x other side, y other side. So 3 minus y divided by 2. That is the value of x here. What is the value of x here? Negative of 2y. Agree? You have
Yes, sir.
function of y to integrate with respect to y. Now, if I take the strip like this, first of all, you have to change this one in terms of your function of y. Then after take the horizontal strip, your horizontal strip, look at here. It starts from here to here. I told you that you are allowed to move from most right side to left side and then top to bottom. So you are moving in this direction, like this and like this. If you are integrating with respect to y, you are moving from right to left. If you are moving integrating with respect to x, you are moving from top to bottom. F minus gx is like this. Here your fx is this one, gx, or fy is g1, fy is this one, gy is this one. So because you are integrating with respect to y, so you are supposed to write this is in the form of fy minus gy. Fy minus gy, like this. So by this function is, yes, please, it was 3 minus y divided by 2. 3 minus y divided by 2. And this part is negative of 2y. Negative of 2y. And your range of y runs from, look at here, negative 1 and goes up to 0. Because after 0, my strip, horizontal strip, will change the behavior from the left side because my function changes. Right? So I have to divide this region into two parts. One is below x-axis, one is above x-axis. Because at 0, 0, my strip, horizontal strip, changes the behavior. And that's what I did over here. Look at here. First of all, I converted my this function in terms of y. This one is in terms of y. This one in terms of y. Then after, these points are already fixed. So it will remain the same. Horizontal strip, most right side to left side, changes the behavior at 0. Divide the region into 1 and 2 parts. So one, you can take this one first and this one part, or this one first. Doesn't matter. It is up to you, right? Usually I go like this. So, or you can take this one. I don't mind. So here it is y runs from negative 1 and goes to 0. Goes to 0. Negative 1 and goes to 0. Most right side, we are moving from right to left. So most right side is 3 minus y divided by 2 minus negative of 2y. Negative of 2y divided. Put the bracket like this so that you can come to know you are not going to make a mistake. Then after my y runs from, this is y equal to now 0 and it moves up to here, it is 1. So y equal to 0 to 1, because you take this strip, allow this strip to come to the initial point, and then after sweep your strip from this initial point to final desired point to cover the whole region. That means y runs from 0 to y equal to 1. Y runs from 0 to 1. And again, we are moving from right to left. So right is 3 minus y by 2 and left is y square. Left is y square and dy. And then the ball is in your court. Just simply term by term integration. Open the bracket. Make sure about the signs. Term by term integration will give you the answer. Make sure with respect to x or with respect to y, if the same figure is there, with respect to x, if you integrate with respect to x or if you integrate with respect to y, both the ways you must get the same answer because area cannot be changed. Area cannot be changed. So both the ways you must get the same answer. Please keep in mind this thing, right? Here also 5 by 3 and here also it is 5 by 3. Look at over here. So many times in the example, I will ask you that set up the integral with respect to x, with respect to y. So you have to follow the direction or what I am asking you. You have to follow that one. Read the example twice before you proceed further. Otherwise, one small mistake will change everything and you will be losing your points. So please keep in mind this thing. Please, 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 guys. Okay. Okay. Next one is question. Question? Fine. Next one, I think it is the same example, just it's a revision. So we did this example, just go through this one, okay? But here I did the same example by both ways. One is, yeah, it's not just actually this first part is a revision, but now I solve the same example using vertical strip as well as the horizontal strip. Means first with respect to X and with respect to Y. Look at over here. So with respect to, actually it should be X, with respect to X, and then with respect to Y. Same thing, guys, but here you are not dividing your region because strip doesn't change the behavior either from top or bottom. So you are good to go. Find the point of intersections. Once you are done this thing, then after you are getting 4 by 3. If you horizontal strip, that means you have to have, now look at over here, x square minus 3x plus 2, and you are looking for value of x now. That means function of y. Function of y over here. This is easy because I can write this y other side, 3x other side. So x will be 3 minus y divided by 3. X will be 3 minus y divided by 3. So it is 1 minus y by 3. Here, look at here, guys. I want x from here. How can you find x? Please be careful. Because I want x here, function of y means x equal to something. So x square minus 3x plus 2. As I told you that you have to have the perfect square. How to find the perfect square? You will not find this thing in the book. So please keep in mind this thing. This L dot S dot means last step. Last step means here I have x square minus 3x. But don't worry about this 2. Just forget this 2. I am looking for one value over here, which gives me the perfect square of this quadratic function, perfect square, right? Not like a minus b whole square, a square minus 2ab plus b square. So I have to find that particular value, and then after I have to add that value and subtract that value because I can't change the function. I have to maintain my 2. So what I'm going to do, last step means perfect square after negative 3x is equal to the formula is, last step formula is middle step square divided by 4 times first step. Middle step is negative 3x, middle step square. So middle step 2 times divided by 4 by x square, 4 times x square, first step. X square and x square will get cancelled out, negative, positive, 3 3s are 9. So 9 by 4 is my last step. But already I'm having 2. So what I'm going to do, I'm going to add 9 by 2 and I'm going to subtract 9 by 2. If you add and subtract like this first part will give me this one. This first part will give me the perfect square, x minus 3 by 2 whole square. X minus 3 by 2 whole square, because x square minus 2 will get cancelled out, minus 3x plus 9 by 4. Perfect square. And here 2 minus 9 by 4 is negative 1 by 4. 2 minus 9 by 4 is negative 1 by 4. I am just adding and subtracting one number just to make the perfect square. And 2 as it is, that means I am not changing my function. Please keep in mind this thing. You are not allowed to change your function. Okay. Now let me send this negative 1 by 4 to other side. So plus 1 by 4 and x minus 3 by 2 whole square. So x minus 3 by 2, that is equal to plus or minus square root of y plus 1 by 2. And if you send this 3 by 2 other side, you are going to get x equal to 3 by 2 square root of 1 plus y over 4. Right? Now look at over here. Your x starts from negative 1. This is your negative 1. And it goes up to 1. X starts from negative 1 to 1. That is, means negative 1 to 1. Look at here, negative 1 to 1. That means you are starting from the negative side. You are starting from the negative side. And that's why it is, I have taken over here 3 by 2 minus square root of y plus 1 by 4. The parabola starts from here. Now minus square root of y plus 1 by 4. Right? So this is my value of x, means function of y here. Sometimes it is important, or I would say a little bit difficult to figure it out, the function of y from the function of x. So please make sure this thing. Once you fix this one, so this is now my function of y 3 by 2 minus y plus 1 by 2. Right hand side already 1 minus y by 3. That means I can do like this. My range is in the range of integration that is also fixed now because we are taking the integration with respect to y, and y runs from here it is 1 and 0. So y is equal to 0 and moves to 6. So y runs from 0 to 6. Y runs from 0 to 6. Strip doesn't change the behavior. So we are good to go. We are moving from most right to most left in this direction. Most right is this one, 1 minus y by 3, minus most left is this one, 3 by 2 minus the square root of 1, y plus 1 by 4, y plus 1 by 4. Just open the bracket, minus 3 by 2 plus this one. And then after merge this y, so here it is 1 minus 3 by 2, 1 minus 3 by 2 is negative 1 by 2 and negative 1 by 2. Right guys? 1 minus 3 by 2 is negative 1 by 2. Or you can do like these two. Look at over here, just first take the integration and then after you can merge. So integration of 1 is y square by 2, so y square by 6 now, negative 3 by 2y, and integrating with respect to y, please don't forget this thing. And here it is negative positive, y plus 1 by 4 to the power 1 by 2 means 3 by 2 divided by 3 by 2. And the coefficient of y is just 1, so you are good to go. Otherwise, you can say y plus 1 by 4 equal to u for this integration. Use u sub. And my in the range of y is 0 to 6. Right? Merge these two y's. You are going to get like this. And then after plug the values, upper range, lower range, negative sign in between. Solve this one. And you are going to get one number. You get over here, it is 4 by 3. Again, I'm telling you, you must get the same area. Either you are integrating with respect to x first and then with respect to y, or vice versa. Both the ways you must get the same number, same answer, because area cannot be changed. And that's the reason I solved this example by two ways. You will not find these type of things in the book. One example is given with respect to x, another example is given with respect to y, but usually authors, I don't know, yeah, I'm also one of the authors, but usually for your book, but usually we don't take same example when we write a book. But when we need to explain at that time, I think if we stay with the same example, students can understand the things that we are getting the same region, we are getting the same answer, we are getting the same area, right? So that's why so many times I've been telling you that teaching and writing a book, both are different things, So many things we have to skip while writing the book, but we have to go to the depth of each and everything at the time of the explanation. Okay guys, any doubts so far? So look at over here, I took this example, I took with respect to x first by taking vertical strip, with respect to y then after that one, by taking the horizontal strip, changing the functions in appropriate form, function of y, and use my algebra skill and got the answer. Any doubt, guys?
No, sir.
Thank you. Let me move ahead. Let me go ahead, guys. My next part is, okay, one more example. This one is just now with respect to y, means horizontal strip. You are given the functions of x. I think all this is exactly the same example. This is root x, this is the equation of line like this. I converted that one in the form of now function of y. So function of x, vertical strip, I took it over there. Right now it is a function of y. So you can merge that example with this one, right? And here it is a function of y. And if you remember, I got the answer 9 by 4. Here also I'm getting the answer 9 by 4. Look at here. So this is another example, but here we are dividing our region into two parts. Look at over, this is one strip. You have to have, I just forgot to draw the strip, but just 1 minute. This is the same one. Oh, it's a y square by 2. Okay, this is y equal to 1 by 2 and y square. So it's a parabola. Okay, this is just one parabola. Okay, I'm sorry. Sorry, guys. This is not a straight line now. This is a parabola. So just one parabola given to you like this, and this straight line. So your function doesn't change the behavior from the left also because it's a parabola. Whole one is just one function. It is not the part of the previous one. I'm sorry. Okay. So this is the another function, parabola like this, straight line, point of intersection. If you solve these two, you're going to get the point of intersections over here. If you solve these two equations, you will be getting your some points over here, some point over here, maybe 1 by 2 and 1. So y runs from -2. Look at over here, -2 to 1, -2 to 1, right? And we are moving from most right to most left, most right to most left. Right is this one, left is this one, and 9 by 4 is the answer. And for the same example, suppose I want to take the vertical step now with respect to x. If you take with respect to x, that means look at my cursor again. You have to divide your region into two parts because your function changes the behavior after this point. Changes the behavior after this point. Because here the upper part is here, lower part is here. Both are parabolas, guys. Please keep in mind this thing. Here parabola is x equal to 1 by 2 y square. That means y square equal to 2x, y square equal to 2x. Upper part is y square equal to 2x, so y equal to plus or minus square root of 2x. Upper part means above x-axis, it is y equal to square root of 2x with plus sign. Below is y equal to square root of 2x with negative sign. Plus sign and negative sign. Plus sign and negative sign. And here x equal to -1 by 2y plus 1. So function of x will be, just take LCM and you can do this thing. 2 1 minus x, 2 times 1 minus x. Now my x runs from here to here first, right? And this point is this point. If you solve these two equations, I have not solved this one, I just leave it to you. If you solve these two equations, you're going to get this point of intersection of these two. That means your x runs from 0, 0 to this number 1 by 2. And then after it goes from 1 by 2 to this point, 1 by 2, and it goes up to here. And this is 1, so here it is 2. 1 by 2 to 2. 1 by 2 to 2. From here it is root 2x minus root 2x. Root 2x minus root 2x. Here it is 2 into 1 minus x minus root 2x. Open the bracket, term by term integration, pull your constants out, algebra skill, second fundamental theorem of calculus. Your answer is 9 by 4. So look at over here, guys. Both the ways you are getting the same answer, 9 by 4 and 9 by 4. Does it make sense? I told you, you will not find a single example in the book, probably any of the books, in which the same example is given with x, with respect to x and with respect to y, and the same answer. I don't know why, but authors don't do this thing. I hope you don't have any doubt. Am I right, guys? All these things are equally important, and please work with me. If you think that you can keep the thing pending for a day and you can do this thing next day or after a couple of days, you will forget everything and you will be having lots of questions. And I'm 100% sure that you will be messing up your exam. So please don't do this thing. Exam is approaching very fastly. Time is approaching very fastly. So please try to. You have chosen this summer course, and you know in summer everything goes really very fast because whole semester 14 weeks course we are finishing just in 4 weeks. Because I don't count 5, I don't say 5 weeks because 1 week that is just for your exams, 4 internals and 1 final. So I don't count 5, I would say just 4 weeks. And 4 weeks, that means you have to 14 fours are, that means you can see almost 3.5 times, right? That means your effort should be at least 3.5 more times than your regular semester. 3.5 more times. And that's why daily I'm telling you that at least spend 3 hours a day. Because in the regular time, suppose you are spending 1 hour, here you have to spend 3.5 times. That means at least 3 hours. Actually, it should be 3.5 hours, but at least 3 hours. Otherwise, I'm sorry, guys. I can only give the advice. I can only solve your doubts. If you have some other problem, I try my best to give you right advice. Try my best to help you out. But ultimately, you have to work hard. No one can help you out. There is no any other options of hard work. No any other alternative of hard work. So please. Okay, now disk and washer method. Disk and washer method to find the volume. To find the volume. It is always better to take the directly. Lots of things are given in the book, the formula, how to get the equation to find the volume by disk method, washer method, all these things are given. Here I would directly start. I will give you the formula and then after immediately I will start with the example, because I don't want to confuse you. If one can go through that whole theoretical portion, how to set up this formula, but I think for you guys it is not required. But if somebody wants me to explain to you, I don't mind. Please remind me at the end of the syllabus. If time permits, we can do this thing. But of course, I'm not asking that. So volume, disk and washer method, I told you yesterday, I just gave you the hint. Disk and washer method provides you the volume of the given region, right? There is some difference between disk and washer. And another method is cell method. Again, if you use disk or washer, and if you use cell, if your region and everything is same, in that case, you must get the same answer because volume cannot be changed. Either you use disk or washer or you use cell method. In disk and washer, again, you are going to go through horizontal and vertical strip. In cell method, again, you will be doing horizontal and vertical strips. So volume, to find the volume by disk and washer, one way is to use horizontal strip. Another way is to get the vertical strip. Same here. To find the volume by cell method, one method is with respect to horizontal strip. Second method, that is with respect to vertical strip. And you have to be very careful. That means there are at least, I would say, 6 formulas, mainly 4, to find the volumes of this by disk and washer method and the cell method. Once you are done with disk and washer method, almost we will be done with this article, or I would say this chapter, because the rest of the things are really, really easy. Really, really easy. Only that will be the matter of calculation. Main part is disk and washer and how you treat those examples. To find the volume by disk method, right now, I would say disk method. I will let you know the difference between disk and washer. So disk method is V equal to pi integration Rx square dx, x runs from A to B. I need to write like this, x runs from A to B. Right? This is the formula to get the volume by disk method. Please keep in mind this thing. What is my Rx? My Rx. Now, in disk method, if you look at the example, if you open your canvas, if you look at the practice test, if you look at the example, here it says that find the volume by disk method. Volume of the given curve by disk, use the disk method to find the volume of the given curve, means this curve, bounded by x-axis, and revolving about x-axis. Look at over here. This symbol, there's the axis of revolution. That means you have one dome like this, or you can have some parabola ball like this. Look at over here, guys. Here is dome, and this is my y-axis, and this is my y-axis. And my axis of revolution is x-axis. That means I'm moving, look at over here, I'm moving my figure, whatever the region enclosed by this, your curvature and the y-axis, I'm moving my figure. Revolution, that is with respect to x, means you are not moving your x-axis, that is with respect to x. That means you are moving your region, whole region, whatever the region in between, I'm moving my region. Are you able to look at me? Are you able to see me?
Yes, sir.
Yeah, so I'm moving my figure like this. Look at here, like this. And I'm coming back over here. That means I'm covering here right now, it is just x and y axis. But if you move like this, that means you are getting 3 dimension and you are getting the volume. So in 3 dimension, it is not the area, it's the volume. Are you getting me, guys? It's like this. See, this is my region, my parabola, my y-axis. And I'm moving like this. complete 360 degree. I'm getting back over here. That means whenever you want to find the area, see, simple thing is, suppose I have one bangle. I don't have any bangle over here. Girls are wearing bangles, or I can say like this. Look, let me use this one. Consider this one as a bangle, right? Suppose I want to find the area. That means area means if I'm able to insert the pen or pencil inside the bangle, that means you can find the area. But suppose there is a bangle with x-axis and y-axis and center is origin. And radius is suppose 1 unit circle. And suppose I want to revolve this circle around x-axis. That means I am now revolving like this. Look at here, guys, please. I'm revolving like this. This is my x-axis. This one is my x-axis. So I'm revolving like this, 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 like this. Again, I'm getting back over here. What is this? Now I'm whatever hollow part was there, I was able to allow insert my pencil over here. But once I revolve the figure, I'm covering all this part, all this part, all this part. Again, I'm getting back over here. That means now I'm filling up all the open parts, and now it's a closed figure. It's a closed figure. That means now in this closed figure, it is not possible. I can just touch the boundary, but I cannot insert my pen or pencil inside the figure. And that's why it's a volume. That means this circle is now converted in terms of a ball. Ball is a three-dimensional figure, volleyball. Am I right? Are you getting me, guys?
Yes, sir.
All of you girls?
Yes, sir.
If you don't say anything, it's hard for me to realize the things, guys. Say something when I ask you. All of you are getting me. All of you.
Yes, sir.
Not just
Yes, sir.
one guy. All of you means all of you. What other guys are doing?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Loudly.
Yes, sir.
I said loudly.
Yes, sir.
Yes, sir.
Girls. Good. Be active, guys. Be active. Be attentive. I know it's early morning, but that's what we have to accept it, right? Don't say that you are tired and you are just feeling sleepy. No, you can have your stimulator with you. This is your home. If it is VMI, we have to follow the owner code. But right now you are at home. Just have your stimulator. Big cup of coffee, tea, something like that. But be attentive, guys. Please don't upset me in the morning. Okay, so now let me continue. So I'm revolving my figure like this and I'm getting the volume. I'm getting the volume. Now look at over here. Whenever you are using disk or was, guys, please try to pick up my words. Otherwise, you will be nowhere. Those who are absent today, I don't know what's going to happen to them.
This is the disk method, right, sir?
This is disk method. That's what I'm telling you.
You were
Disk
saying like
method means, please, I took this strip. Am I right? I take this strip.
Yes.
Disk method, why I take this strip? Again, look at me. Look at me. My figure is like this. I have started my strip from top to bottom. Can you see? And what is my axis of revolution? What is my axis of revolution?
The x-axis.
X-axis.
X-axis. Good. Just reply me immediately, please. X-axis. Girls, you guys too, please.
Yes, sir.
Yeah. So can you see after taking the strip, my strip touches the axis of revolution? Try to pick up my words. I don't say x-axis because axis of revolution could be anything. It could be y equal to 1, y equal to 2, y equal to 0, y equal to 0. Right now, in this case, it is x-axis. But it could not be always x or y axis. It could be something different too. So that's why I used my verb in the full sense that my axis of my strip touches the axis of revolution. Agree?
Yes, sir.
Yes, sir.
Whenever, very good. Whenever your strip touches the axis of revolution, that is called disk method. But sometimes it may possible. Suppose I give you, I change my example. This figure is bounded by the curve, and then y equal to 1 line passes through this one. Am I right? Look at my cursor. Agree? That means now I'm counting only this region, but I'm not counting below 1. Agree? I'm just counting this region. This region. above y equal to 1. But my axis of revolution is this one. That means if I draw the strip, I have to stop over here because that's my region. Agree? That's my region. All of you are getting me or not? All of you are getting me or not?
Sir.
Yes?
Can you say that
Listen.
again?
Okay. So my axis, my strip will not touch the axis of revolution in that case. Whenever your strip doesn't touch the axis of revolution, it is like perpendicular to the axis of revolution. See, in disk and washer, both the methods, your strip must be perpendicular to the axis of revolution. If I say revolution is x, you don't have any other choice except vertical strip. Because my vertical strip will only perpendicular to the axis of revolution. Okay, guys? You cannot take horizontal strip over here because it would be parallel to the axis of revolution. In this washer, both methods, your strip must be perpendicular to the axis of revolution. The difference between disk and washer is, in disk method, your strip touches the axis of revolution. In washer method, your strip does not touch the axis of revolution. Just now I gave you the example, right? Suppose I take another line y equal to 1, and area bounded by this region, I'm going to find the volume of this area, volume of this one, bigger by this curvature, y equal to 1. And I'm revolving the figure about x-axis. In that case, my strip does not touch the axis of revolution, and that is called the washer method. Right now, I would just like to focus on these two methods. I don't want to discuss cell method right now. When the time will come, I will let you know. Not right now. Once I want you to understand this concept of disk and washer thoroughly, then after we will proceed further for the cell method. Sounds good?
Yes, sir.
Good, thank you. Davis Alexis, what are you doing? Rachel? Rachel?
Yes, sir.
Good. Okay, guys. So what is my Rx now? So Rx is my top part of the strip. Suppose this is, I would say Fx, and this is Tx. So it is simply Fx minus Tx. Top part of the strip minus bottom part of the strip. So F minus Ts. Here my Fx equal to, means y equal to 3 minus x square. Bottom part is y equal to 0. So 3 minus x square minus 0. So it is 3 minus x square. So square is there. If whole square, perfect square, integration, term by term integration, and pies out. Second fundamental theorem of calculus, replace your x by √3, then x by negative √3, in between negative sign. That's what I did over here. Simplify this one. If you simplify, you're going to get, this is the answer, and that is your volume. Does it make sense?
Yes, sir.
Any doubt, guys, so far?
No, sir.
You might
No,
have
sir.
observed, I just decreased my speed. I am moving very slow right now because I know these things are not that easy for you guys to digest immediately. And that's why I decreased my speed like this. And again, guys, if you have any doubt, you can interrupt me. I don't mind. You can interrupt me. Okay, guys? I don't mind to answer you 2, 3, 4 times. You can interrupt me anytime. But please give me your name first because I can't see all of you while teaching over here. My focus is on my screen and I can see few of the pictures, or 5, 6 pictures over here, but I can't see all you 23 guys. So please, when you ask the question, first give your name and then ask the question so that I can come to know who is there, right? Classroom, I don't want to ask to know your name because you are in front of me, but here slightly different situation, but that's okay. We are not losing anything, right? It's almost same as the classwork teaching. Yeah, it's a little bit more time for me because grading takes more time. In classroom, I would say hard paper, I can grade very immediately. Here I have to spend more than 5 times more than my hard papers grading. Right, but that's fine. Okay, one more. Volume. Bounded by. Again, if you look at the example is like this. Find the volume by disk or washer method. Always I'm mentioning like this, disk or washer, because you guys are the right person to decide whether you are using disk or washer, depending on the nature of the strip, whether your strip touches the axis of revolution or not. Or if it touches, disk, does not, washer. You know it.
Sir, I have a question. This is Judith.
Your voice is getting echo. Please say again. Who is there?
I have a question. This is Judith.
Okay.
Okay. So the disk and washer method, are they both the same formula? It's just is it the same formula for both?
Same formula for what? Fx minus gx.
Okay, thank you.
Equal to Rx equal to Fx minus gx. But here, slightly different formula. I'm sorry, slightly different formula there for washer. Here it is because actually your Rx is nothing but, okay, let me explain to you guys. I think she raised the right question at right time. Let me stop sharing this screen. Just 3 minus y square and okay. Let me stop sharing this screen and let me start my whiteboard. Okay. So it was something like this. Why is bothering me? Clear all drawings. Again, let me start. Okay. Figure right now is something like this. Agree? And this one is nothing but y equal to 3 minus x square. And my Rx, whatever I told you, that is equal to Fx minus Gx. Fx is this function. So here your Fx is your y. So Fx equal to 3 minus x square. And bottom function is my Gx. Gx equal to y equal to 0 because it is x-axis. And this is my axis of revolution. This is x-axis. Right, guys? This x-axis. And that's why if I take the strip like this, if I take my strip like this, right? This is Fx minus Gx. So I can write that is equal to 3 minus x square minus 0. That is equal to 3 minus x square. And then plug this value in the formula. But now, as I told you, I would like to give you another form. Look at here. This is my axis of revolution. That is my x-axis. This is my y-axis. This is 1, 2, and 3. And this is the line, suppose y equal to 1. This is the line y equal to 1. So now my figure is bounded by, this was the area here. Here now I restricted my area. It is now bounded by the curvature y equal to 3 minus x square. Y equal to 3 minus x square. And then line y equal to 1. Now if you take the strip over here, if you take this strip, your Rx will be here to here, there is your capital Rx. So your capital Rx will be Fx minus I would say this is my G, okay, this is my G, you can say, okay, Gx, y equal to 0. So Fx minus Gx. So that is equal to 3 minus x square minus 0. And I have to go for this region that is called small rx. So small rx equal to Rx equal to, now it was my Fx and Fx minus, I don't want to say G here, let me write Fx minus Qx. Let me write Fx minus Qx like this. And this is my function G. Gx equal to y minus 1, that this line, y minus 1. So Rx equal to now Gx minus Qx. And that is equal to Gx equal to y minus 1, y equal to 1. So it is 1 minus 0. That means for Wasser method, it is Rx minus small rx. That is equal to 3 minus x square, that is Rx, and small rx is 1 minus 1 is 0. Agree? So 3 minus x square minus 1. That is equal to 2 minus x. So for disk method, my formula is, yes, volume V equal to pi times integration x equal to a to b, and here it is capital of Rx, whatever you figure it out, square and dx. That is for disk method. For Wasser method, Wasser means this one. For Wasser method, my formula will be V equal to pi integration capital of Rx minus small rx and whole square and dx, and x runs from a to b. Does it make sense, Judith?
I didn't get that last part of the formula where you said the x squared or something like that. Can you just repeat that?
I can't hear you.
I didn't get the last part of the formula. I got the Rx minus little rx. But what's after that?
Last part, this one?
Yeah.
This one?
Yes, sir.
Look at here. I am taking from here, let me change the color, maybe useful to you. I am taking from here to here. That is my capital Rx. So top part to bottom part, because that is my axis of revolution. So you have to go to the top part to the axis of revolution. And then after small Rx, that is my bottom part of the strip to the axis of revolution. So this is my bottom part. This is my small Rx. So this is my small Rx and this is my capital Rx. This is my capital Rx. Are you getting me? This is my capital. And we are taking the difference between these two so that we will be having this part. We will be having this part. So that is the formula. Is it okay now?
Yes, sir.
Okay. Any other doubt, guys?
No, sir.
Any other doubt? If you have any doubt, you can ask me, guys. John, are you okay?
I said yes, sir. I'm fine.
Oh,
This is good.
thank you. But the area?
I'm good, sir.
Good. Cooper? Carpenter? Ismail is there or not? Simon, Ismail? Okay. Good.
Simon's here, but
Simon is
Taylor's
here?
not.
Simon is here?
Yeah, but I think he's on his phone, so I don't know if he can talk or not.
But he is
Okay.
here, sir.
Simon is here, right?
Yes, sir.
But he has to be very careful. Guys, do one thing. If our class starts at 7:40 or 7:30 like this, you have to be online for at least 5 minutes so that something goes with your computer or connection. You can fix that problem in those 5-7 minutes. That I am online at 7:45, suppose you will be exactly at the same time. No, you start your computer and make sure that everything goes well from your side. So please try to have your seat at 7:35 to 7:40 so that when I take your presence at that time, you all are here and I don't miss any one of you. If I miss any one of you more than 2 times, I have to send. Yeah, that's the rule. I have to send the report. I have to email to the summer school and the registrar's office. Yeah, I'm sorry, guys. I don't want to pressurize you like that, but that's the rule, guys. And I think that is good for us too, right? Anyway. Okay, guys. So may I stop this sharing of the screen?
Yes, sir.
Finish this part. Stop sharing, and again, let me go back to my problem, my function, right? Okay. So now this is disk method. Already explained to you disk method. C3 minus x square. You want to find now. You have to have your how I fixed my -3 to 3. That is important. For that, again, you need to solve these two equations. One equation is 3 minus x square. Another equation is equal to 0. I'm sorry. Another equation is 0. So 3 minus x square equal to 0. So x square minus 3 equal to 0. So x equal to plus or minus root 3. Right? X equal to plus or minus root 3. If you plug that value over here, you're going to get y equal to 0. So naturally, negative root 3, 0, and plus root 3, 0. These two are the points of intersection, or you can say x-intercepts. X-intercepts. And that will allow you to take the range of integration, then simple calculation, and this is the answer. Okay, second problem was volume. This is my, here to here is my Rx, so it is 5x minus 0, simplify x square pi, range of integration runs from 1, because with respect to x-axis, so 1 to 2, don't forget pi. You are getting volume now, so formula says that pi should be there. So don't forget pi, and this is the answer. Now another example, I would like to consider now Wasser method. Wasser method, guys, please be careful for one of the examples, question number 5A in your practice test. You are given, see, this region area, like picture will not be provided to you. I'm just going to provide you simply the equation. And you need to fix your, suppose I write, find the volume by disk or Wasser method. Question is like this. Find the volume by disk or Wasser method bounded by the graphs y equal to root x and y equal to x. That's it. And my job is over. I repeat. Find the volume by disk or Wasser method bounded by the functions y equal to root x and y equal to x. If I write y equal to root x means y equal to, or y square equal to x, means the parabola in first and fourth quadrant. But y equal to root x is the parabola in the first quadrant, and y equal to negative root x is the parabola in the fourth quadrant. Because I am asked to go through y equal to root x, so let's go for y equal to root x, just the first quadrant. And y equal to x is a line passing through this thing. If you equate these two, y equal to root x and y equal to x, if you equate these two, I did not over here, but if you need to equate these two. So y equal to root x and y equal to x, so x minus root x equal to 0, right? Or you can make a square, what you want, and you're going to get the point of intersection 0, 0, and 1, 1. Because you are taking now, look at here, guys, because you are taking, what is your axis of revolution? Your axis of revolution that is given to you with respect to y. So I'm sorry, but my problem is like this. Use disk or Wasser method to find the volume of the functions bounded by y equal to root x and y equal to x revolving about y-axis. Revolving about y-axis. Revolving about y-axis. Judith? Judith?
Yes, sir.
For you, look at here. Now, first of all, with respect to y-axis, disk and Wasser demands that my strip must be perpendicular to the axis of revolution. That means I don't have any other choice except the horizontal strip. Agree?
Yes, sir.
All of you?
Yes, sir.
Sheriff, Chris?
Yes, sir.
Good. So I don't have any other choice except the horizontal strip. Horizontal strip means you know this thing that we are integrating our function with respect to y. we cannot change the theme. Please keep in mind this thing, right? We are integrating our function with respect to y. That I have to have function of y for, it is a function of x right now, but I have to have function of y now. So y equal to root x means x equal to y square. Y equal to means x equal to y. See, I wrote it down very clearly for you. X equal to y. So one thing is done. Second thing, Judith, look at my cursor. My ry, capital Ry is top of the strip or most right side of the strip. Soto's Wi-Fi is not working. Just send the email to me. Oh my gosh, we are doing extremely important thing right now. Anyway, so my capital Ry that starts from here to axis of revolution here means it is y minus 0. Agree? I know y minus 0 is simply y, but it could not be every time. It will not be every time just revolution about y axis. It could be something different too. That's why I just wanted to follow the formula. So Ry equal to this my most right side to the axis of revolution, y minus 0. My small ry is the bottom part of the strip to the axis of revolution. Bottom part is y square minus 0, so y square minus 0. Agree? Don't forget ry. You are taking ry square minus small ry square. It's not ry minus ry square, guys, please. So ry, then square, then minus small ry, then square. Wasser method. Why Wasser method? Because your strip does not like the axis of revolution. Look at here. It is little far away from this one. Some gap there. Once you set up the formula, plug the values, get the answer to y 5. Simple. Main thing is to understand your problem and to set up the formula. And then different problem. Now about y-axis. Okay. Volume of the function by Disch-Wasser of a function y equal to 3 minus x square and y equal to 0 about y-axis. Here also it was a y-axis, now also it is y-axis. This is your region, and also it is x equal to bounded by y equal to 0 and x equal to 0. That means just the first quadrant. So we are taking, this is x and y axis, and we are taking just this portion, not the other side, just this portion, and this portion we are revolving about y axis like this. We are revolving about y axis. Look at me, guys. This is just this portion, and I'm revolving like this. I'm revolving like this. I'm revolving like this, like this, and like this, and I'm coming back, and I'm getting the full region, full volume. Are you getting me?
Yes, sir.
Good.
Yes, sir.
Good. So now, because it is with respect to revolution around y-axis means you have to maintain horizontal strip, because only horizontal will be perpendicular to the axis of revolution. Rachel, right? Here, please. Okay. So my axis, my strip touches the axis of revolution. So simply Disch method. So my Ry is, for make a function of y first, 3 minus x square is 3 minus y, because first quadrant's a positive sign, so square root of 3 minus y. And it's square and pi outside. Plug the values, get the answer. You're done. Simple. Simple. One more. Y equal to 4 minus x square. Y equal to minus x square about x-axis. So now it is not like this, not 3 minus x square, but it is now 4 minus x square, means your parabola will go through number 4. Look at here, number 4, because it's 4 minus x square now. Parabola opens down and goes over here. 4 minus x square. Okay, guys. Now look at here, about x-axis. First of all, about x-axis. So revolution about x-axis. Means we have to have, now it's not just first quadrant, it's the full part. We have to have the perpendicular strip like this, because vertical strip only is the perpendicular strip to the x-axis. So my Rx equal to 4 minus x square minus 0, n square, pi outside. Range of integration is, if I solve these two equations, negative 2 to 2, so negative 2 to 2. Get the answer. Most important thing is this one. Same figure guys, but now I'm changing my example. All of you, pay your full attention. Changing my example. Axis of revolution is not now x, not y. Something different than x and y. Suppose line y equal to 4, line y equal to 6. Something like that. Yes. As usual, I am taking varieties of examples. So this is about the line y equal to 4. Y equal to 4. If you take x equal to 0, minus y equal to 0 x-axis, my strip touch the axis of revolution. But if you take now y equal to 4, my strip does not touch the axis of revolution. Look at here. Now I am using Wasser method. So I told you it is you, only you, to decide whether it is disk or Wasser. And that's why I'm going to ask you like just disk oblique Wasser. Decide yourself. And that's easy. So y equal to 4, I have to consider the vertical strip because it is disk and Wasser. This vertical strip is the only perpendicular strip to y equal to 4. Agree guys? Y equal to 4. Good. So my Ry, be sincere guys, be careful. My Ry, what is Ry? Ry is the distance from the, yes please, distance from the axis of revolution to the strip. Axis of revolution to the strip. So strip is, long part is here. So axis of revolution is 4. So this 4 to this one is my capital Ry or Rx, sorry, because vertical strip is there, right? Rx. So Rx equal to this 4. Look at here, 4. That's why Juliet. That's why I told you that use Rx equal to this fx minus qx, something like that. So 4 minus 0, and my small Rx is small Rx here to here, and now here to strip. Actually, it is not this, it is this one. Here to strip. So it is 4 minus strip is 4 minus x square. So 4 minus x square. 4 will get cancelled out, negative, negative, positive, so it is x square. So small Rx is x square. Are you getting it, guys? Are you good with this capital Rx and small Rx? Do you understand this thing?
Yes, sir.
Sir.
Good. All of you girls?
Yes, sir.
Davis, Alexis, Rachel, good. Judy, all you guys are good, right? John, Thomas Williamson,
Good, sir.
good. So now, once you fix your small Rx and capital Rx, again, capital Rx is a distance from the strip to the most right side of the function or most top part of the function or the bottom part of the function. So long distance is capital Rx, small distance, axis of revolution to the bottom of the strip, that is small Rx. Here 4, this is the curvature, equation of curvature is 4 minus x square. So 4 minus x square, open the bracket, x square. If you do like this, almost you are done guys. It's just matter of calculation. So v equal to pi, x runs from negative 2 to 2. And then capital of Rx square minus small Rx square is this one, small Rx square. Capital Rx is 4 minus 0, so it is 16. Here 4 get cancelled out, negative, negative, positive, x square and square is x to the power 4. Integration. And the answer is simple. Agree? Agree?
Yes, sir.
Let me take one more example. example about y equal to -1. Y equal to -1. So same figure. See, I'm just with the same figure. If somebody is there with the railway crossing, who is there? No. Okay. So look at here, guys. About line y equal to -1. My figure is this one. This is 4 minus x square. Y equal to 4 minus x square. But my axis of revolution is y equal to -1. This is my axis of revolution. Whatever examples I took it over here, you will not find these varieties of examples in the book, guys. Please. Trust me. Y equal to -1. Y equal to -1. This is my axis of revolution. I am asked to use either was or disk or washer. Y equal to -1. My figure ends over here with y equal to 0. That means my strip is like this. Because I'm using disk or washer, I have to have the vertical strip because that's the only perpendicular strip looks like my axis of revolution. Only perpendicular strip to the axis of revolution. So it has to be vertical strip. I have to end over here. My capital Rx is starting from this top part of the strip to the bottom of the, to the axis of revolution. So top part of the strip, there is a curvature. That is 4x minus x square, 4x minus x square to the axis of revolution is -1. 4x minus x square minus -1. 4x x square minus -1. That is my capital Rx. In short, capital Rx means we are always moving from top to bottom or most right to left. Please keep in mind this thing. So here is top to bottom, this one. In the previous example, it was top to bottom. Top was 4 and bottom was this one. Right? So just keep in mind this thing in a very layman sense, very rough sense, that capital Rx or Ry is, Rx is top to bottom, most top to most bottom, right? Or most top to the smaller bottom, you can say. And here it is, most top to bottom, distance between the curvature to the axis of revolution, most top to bottom. So that's why it is 4 minus x square minus 1. And small Rx is bottom part, y equal to 0 to y equal to -1. So 0 minus -1, 0 minus -1. Makes sense, guys? I'm saying, make sure this sign makes a big difference. If some small error is there, everything will be wrong. Your example, your answer, your volume, everything is wrong. 0, r equal to 0. This is my small r, x, r equal to 0 to -1. So 0 minus -1. And in between negative sign as per the formula. And you get the answer. Agree? Agree, guys?
Yes, sir.
The last example, I know it's too much work for you guys. Last example, and then we'll stop. And then after, my blank pages are there. Oh, I'm sorry. Chapter 7 starting from beginning. Okay. That's fine. This is a practice test, guys. This is a practice test. This is a practice test. Okay. One more example about x is equal to 2. Same DOM. 4 minus x square equal to 2. X equal to 2 is a vertical line. To revolve your my figure around this line. Disc washer method means your strip has to be perpendicular to the axis of revolution. Means I don't have any other choice except horizontal strip. Agree? Except horizontal strip.
Yes, sir.
Okay. So I have to first fix my capital R. Horizontal means you have to have the function of y. It was given y equal to 4 minus x square like this, but you have to have the function of y. So x square equal to 4 minus y, x equal to plus or minus 4 minus y. Plus or minus 4 minus y means this is my y-axis. On the left side of y-axis means this part. x equal to negative square root 4 minus y, and the right side of y-axis, this part, it is x equal to positive square root of 4 minus y. Keep in mind this thing. Positive, and here it is negative. So negative 4 square root 4 minus y, that is this curvature. Positive square root 4 minus y, that is this curvature. Thing is done. Second thing, I want to fix my capital of ry, because now it's a horizontal strip. So ry, not x, because we are integrating our function with respect to y. My capital ry, you can see over here, I put this picture. So it starts from always moving from most right to left and top to bottom. Most right is this one, x equal to 2 axis of revolution. There is 2 minus this one, 2 minus this curvature. This curvature is negative square root 4 minus y. So 2 minus negative square root of 4 minus y. Agree? Minus sign makes a big difference. Good. Then after my small ry, most right to left. 2 minus curvature is now, this is positive side because it is other side of x-axis, first quadrant. So 2 minus square root of 4 minus y. 2 minus square root of 4 minus y. Square root of 4 minus y. Because this minus and square root is there, so just open this bracket, you're going to get 2 plus square root of 4 minus y and square. And 2 minus square root of 4 minus y and square. A plus b whole square, a minus b whole square, a square minus b square. So it is 4 minus 4 minus y. 4 minus 4 minus y. Oops, oops. I did not solve this one. Okay, I think that's simple. 4 minus y. And then go for the integrations of 4y minus 4 minus 4, right? A square minus b square. So 4 minus y. So 4 minus 4 minus and plus will get cancelled out, minus plus. So it is simply y and square, y cube by 3, range is 0 to 4, pi, and the answer. So that's all about the disk and washer method. Number of examples are there. Number of examples I give to you over here in the practice test 2. Okay, guys, so let me stop over here. It's almost 9:25. Let me stop over here. Yeah, I don't give you any break because we are starting 5, 7, 10 minutes because of that. Colorado, John, right? Hey, John,
Yes,
what is
sir.
the situation over there?
The situation over here
Yeah,
regarding
because I heard that lots of riots are there because of that,
I'd say
murder.
that the ride's actually doing pretty well. I think the one place that's bad is Colorado Springs because there's a pretty big Ku Klux Klan place there.
Right.
So the KKK is pretty huge, Colorado Springs.
My gosh.
So it's a little whack down there. But up in Denver, it's pretty chill. The police here are pretty calm.
Yeah, I came to Denver in the month of January. It was a little cold, but I like that city. It's a beautiful downtown.
Super
Awesome.
pretty.
Super
Super
pretty.
pretty
Yes.
place.
Yeah.
Yes, sir.
And people are also good over there. Yeah, I spent over there almost a week, and yeah, I really enjoyed it.
I mean, everyone here's pretty calm because a lot of them are smoking weed, so they're all pretty chilled out.
Right.
All right, thank you very much, sir.
Thank you, guys. If you have any doubt, you can ask me. Otherwise, stop over here. What do you want? So I stop here. I think I explained to you everything, and tomorrow we're going to start the cell method. And once you're done with cell method, as I told you, almost the part of the chapter is done. Then after just the arc length and surface of revolution about x and y axis, some small stuffs are left out. And that's not a big deal. Right, guys? Thank you so much, guys. Again, let me you please try to watch my videos if you have some doubts. I request all you guys, please watch the videos, subscribe it, and try to solve the homework assignment problems. Do this thing. Thank you, guys, and yep. Let me close this one and let me stop sharing my file. Let me stop this one. You guys are requested to come online in time, please.